Hello all and welcome to this session. My name is Eliran Natan and I'm happy to be here in React Summit. Today I will talk about intelligent prefetching in React. So we start by talking about prefetching of code. Later we show how we can predict the user behavior using machine learning. And finally we combine those solutions to form fast React applications. So I want to start by talking about the context. Usually we are building those amazing single-page applications, and eventually we turn out with this huge bundle size that eventually causes problems in loading times, slowness, and potentially harming the user experience. So what we can do is to use the React code splitting API in order to import components on demand. So here, instead of just importing the chart component, increasing my bundle size, I'm lazy loading the chart component, and the actual fetching of code would happen only when we render it. But that does not solve the problem entirely, right? Because we are just shifting the fetching time to somewhere else. Whenever the user will actually want to render this chart component, then it will have to wait for the fetching to occur, and that can affect the loading time and harm the user experience. So what about this crazy idea? We could break this trade-off by prefetching the chart component. So using the time that the user is just staring at the screen, and before it ever reaches the chart, we could prepare this content. We could use the dynamic import feature to dynamically import the component and then overriding this variable. Now we could do that if we had some indication or some educated guess about the user's next move. We could use this trick to further increase the performance of our applications if we are doing that for entire routes. So if I have this routing between dashboards and products, I could use lazy loading to lazy load those routes, and then conditionally, if I have some indication about the user's next move, I could dynamically import those routes, saving a lot of time. So that brings us to the question, and that's a very interesting question, of how we can predict the next move of user. So let's just analyze this question for a bit. We have this complicated single-page application that is combined from a lot of different components. And we can list those different triggers, those actions, links, buttons that the user can interact with, or at least those that are interesting in the sense that they would cause a rendering of other large components. Now we could keep track on the user's behavior or make this perform this ordered sequence of interactions that the user is performing. And the question here is how we can based on this sequence, how we can predict the next element in that sequence. So what we need is this intelligent mechanism that receives a sequence and returns the prediction or estimation of the next item in that sequence. And in machine learning, we call this problem sequence prediction. So we can use supervised learning, specifically a neural network, in order to figure out that this estimation. So a neural network would receive an encoding of that sequence as this series of numbers. Each number is the identification of a certain trigger, and return this probability distribution across all the possible triggers that the user can interact with. So each output would represent the chance that corresponding element will be the next element in the sequence. So this is a supervised learning, and the neural network acts as a function approximator. the function that receives a sequence and returns a probability distribution. Now, once that we have this output, we could just take the maximal argument and derive from that the next UI element that the user is about to interact with. Now, of course, those predictions will be meaningless unless we train the network. So in supervised learning, we have to supply the network with examples. And the best source for those examples is the actual behavior of the user. So we could sample the behavior of the user, taking those sequences and feed the neural network with those examples. Basically telling the neural network, this is the actual behavior of the user. Please adjust your predictions accordingly. So I think it's cool that we are using the user in order to train the application. So the more that the user uses the application, then it trains it accordingly. And when the user changes its behavior over time, then the application can adapt. Now, specifically speaking about implementation, this predictor can be implemented as a neural network. And what we are seeing here is that the input of that neural network would be we are using here one-hot encoding instead of just pure numbers. And this is because we want to break any numerical correlation between those elements. There is no meaning to say that a dashboard is smaller than products because it is represented by the number 3 and not by the number 21. So this is the way to break this correlation. Now, once that we have the most important thing in the architecture of your neural network is that we have to use this LSTM type of neural network. This is the best type that can support sequence predictions. It is also important to notice that the input layer the number of units in the input layer should match the length of the sequences that we are working with. And the number of units in the output layer should match the number, all the possible triggers that the user can interact with. Now, once that we have the output from that network, we can attach it to the corresponding element in the user experience and assume that the user is about to hit this element.